Thanks, James. Hello, everybody. This is really just a quick overview of some of the processes that we're getting into to actually put public geoscience data out there. Lana touched on a lot of these initiatives, and this fits squarely into that. What we've been doing since about 2022 was to look into different data sources, including satellite data, to help us and support us in the mapping efforts that we're undergoing. This is the only technical slide I'm going to include, promise, so please bear with me. This is simply to highlight the electromagnetic spectrum between the visible spectrum, so anything we can see with the naked eye, and anything that we can see on the electromagnetic spectrum as it is put out by the sun. Really what this tells us is that we can look at rocks and we see it with the naked eye as a brown rock or a green rock, and that already tells us a lot, but that is only using this little bit here of the spectrum. If we use the entire spectrum, we can learn exponentially more about rocks, and that's really all there is to it. Between multispectral and hyperspectral, the difference is really only that for multispectral, we use multiple bands. For hyperspectral, we use continuous coverage across the electromagnetic spectrum. There are a couple of satellites in space that collect this spectral data for us. The big ones are Landsat, Sentinel-2, and Aster. Those data sets are freely available, and so we are using them and utilizing those data sets to the best of our capacity. But there are limitations there for spatial resolutions. The pixel size is usually pretty coarse, so there are limits to how much we can use this. Worldview 3 here is a commercial satellite that is the exception to this, has much better resolution, but the data is either costly or includes proposals to be put forward to acquire that data. This was my background. This is how multispectral data can look like in areas where it works really well. This is a desert area in Arizona, and if you look closely, you can see these different colors. It doesn't really matter what they are at the moment, but the different colors here, the dark rocks, the pink rocks, something in blue, all of that is lithologic information that tells us something about the rocks on the ground without even setting foot there. So there is a lot of information we can gather from this. If you look closely, I don't know if the resolution is good enough, but in this dark band here, you can even see some tight folding here. So it's lithologic information, structural information. It's fantastic, fantastic use of, fantastic resource for our purposes. Now, when I started at the survey in 2022, I jumped to the same conclusion that we could do the same thing in the province and jumped in and tried the same thing for a region in Labrador, and this is what came out of it. A big brown blob of nothingness. This was a bit of a setback. You can imagine just starting a new position, being all excited, and this being the first thing that you come up with was not ideal, but there was a reason for this, and that is mostly this. Many of the outcrops that we're dealing with are lichen covered. The lichen attenuates any electromagnetic signal that we get from the outcrops, so there is a limit of how much we can actually see when we look at the outcrops. On top of that, we've got weather. RDF is just something we never are going to move away from. Humidity in the air is an issue that we have to filter out from these satellite multispectral data sets. All of those are complicating factors that we don't have where this kind of data is usually applied. But as Lana just pointed out, at the rate that we're currently going at, it'll take us a long time to cover Labrador, including the 30 years that it's going to take me to map the Hopedale block, as I just learned. So any step up that we can get is useful and will help us to reduce this time and make fieldwork more efficient. And that's really, that was my motivation to dig into this a little bit further and see what we could get out of satellite data after all. First thing I did was to compile the freely available data. I'm going to show now an example of Sentinel-2 data that was very simply processed to show us the abundance of iron at the surface. So iron-rich minerals, any rusty spots on the surface, and I did that for the island, and this is what it looks like. It doesn't look great, as was expected, but if you look closely, you can see that there are certain areas here where there is a lot of iron on the surface. Not surprisingly, one of those was around the Bay of Islands here, the ophiolite complexes, because there's not much lichen growing on those rocks. So I looked into if at least there we could use satellite data properly, and it worked really well. There I processed, this is again, the colors don't really matter, but we can tell different rock types in the Bay of Islands area apart simply by looking freely available satellite data. So this was fantastic news. All of these orange, purple, blue, yellow colors there are all differences in the exposed rock. So this is something that we can use to produce a remote predictive map and take that out into the field and ground truth it and use it to inform our fieldwork efforts. The next step then was to apply this kind of workflow where it counts, so to say, in Labrador, where it's much more expensive to do fieldwork, where we can really, where we could really use any advantage that we can get. So I used this map here. This is a map of the Harp Lake intrusive suite that Elena just touched on briefly too. And I'm just going to zoom in on this eastern part here around Harp Lake. And the only thing I want to highlight here is the distribution of these little crosses. These are ground observation points, so that's where the geologists were actually on the ground and collected information. And there are two things that you'll see here. All the contacts between the different rock types are inferred. They're all dashed lines. Very few of those were confirmed. And the density of observations and the level of detail depends very much on where the geologists actually were. There's nothing wrong with that. We can't avoid it. But it's one of the aspects of fieldwork, especially on the scale of mapping that we often do in Labrador. Now, if we overlay this area with the satellite data, we can actually see that there are color differences. This processing took a little bit longer, is a little bit more involved, but it brings out different colors. And I really only want to highlight the areas of these green rocks here, then the dark blue purple rocks, and these pink rocks here in the middle. Those are true lithologic differences that are brought out by freely available satellite data processed right. So this is a huge help for anybody who's now going into the area. We can produce a remote predictive map very crudely. If we just draw in some contacts, might look like this. And if we compare that to the existing map, we'll see that some of these contacts overlap remarkably well. So this one up here actually works really well, but there are also others where there's just no contact mapped in at all. So this would be an area where some follow-up would be warranted to confirm why the satellite multispectral data brings out differences that are not captured in the map. Without any extra effort, no other investment required, a day of processing data in the office, and already the next field geologist will have a very valuable resource at their hands to inform and organize their field work, essentially where they go in order to update the map. We are then moving a little bit north from this area, from the Harp Lake area here to this area here, which is newly acquired Worldview 3 data. We put in a proposal that was successful and got 150 square kilometers of high-resolution multispectral data. That is in this area here on the boundary of the Hopedale Block and the southeastern Churchill province. As Alana mentioned, we've got a couple of new geologists that are working in this area, so we were trying to support them as best as we could and put forward this proposal. This data was acquired earlier this year. And I just want to highlight here how much of a difference it actually makes resolution-wise. We zoom in on one of these outcrops here, this one here in the middle. It's about 4 kilometers long. And if we overlay that with the freely available ASTER data, it doesn't tell us much. There might be some color differences here, but it's just not fine enough. We don't see enough to make a good remote predictive map. If we use the Worldview 3 data, it's a whole different ballgame. We can immediately see there are more of these red colors down here. I don't know if the projector brings that out, but these ones here are a different shade of red color, and it's generally more green rocks in the northern part. So there is information there that we can get out of higher resolution data that we just couldn't from the freely available material. We can also take the processing a little bit further. In this case, the scale here, this is 50 meters, so this is a true outcrop scale mapping that we can do with this Worldview 3 data. And if we process it properly, we can threshold the abundance of iron on the surface, which is what I did here. So red areas contain a lot of iron at surface, white areas don't. The problem here is that this is all modeled. This is not ground truth, and we don't know what this threshold actually means. We don't know if it's 10% iron-rich minerals, if it's 50%, we need the boots on the ground to confirm that. Otherwise, what we're doing here is useless. So we need to have this layer out in the field with the geologists, confirmed by the geologists, and then reworked into the system to be confirmed. So to bring together the tools and applications that we're actually using here, the satellite data that we have at our hands, both the freely available ones and the ones that we have to apply for or pay for, can support and do support bedrock mapping and superficial mapping in the province. We have tried this, this works. But it can really only do this. It can only support. We cannot set up a remote predictive map that we accept as the truth. And I mean, as a geologist, the last thing I want is some glorified tin can somewhere in space to tell me that I'm standing on a grounded diorite, where in reality it's not that. There are pieces of information that I can get out of this, and it's hugely valuable, but it will never replace any efforts in the field. It can make efforts in the field more efficient, but we should never take the results coming out of this as truth. We can only always use it as piece of information to improve our workflows. What we can do is identify areas of hydrothermal alterations or Gaussians. Greg Sparks and colleagues did an initiative in 2022-23 in the Long Harbor group on the West Coast, where they were able to successfully identify areas of hydrothermal alteration. It doesn't quite apply to the area where we're working in Labrador and just got the recent Worldview 3 data, but depending on where we go next, this kind of data is fantastic to identify areas of hydrothermal alteration and all the associated potential for mineral deposits. The next steps here, and the steps that we took before, are really we completed a proof of concept. This works in the province. We have compiled all the free data that we can get our hands on. We are a fair way into the data processing. We are currently in the process to semi-automate all of the data processing to make that more efficient, because we don't have a designated position for this. This is all just something that we kind of do on the side as the team. So the data processing is still being made more efficient and quicker. And then the next steps are going to be a continuous expansion of the high-resolution data coverage. We are identifying areas of interest where applications for Worldview 3 data would be warranted, and we are continuously going to do that. And then it is also going to be to combine, as Elena highlighted earlier, the multispectral radar geophysics data that we have using machine learning and AI. We have started doing that, and it's very promising. This kind of data is ideally suited for those kinds of algorithms. Random forest neural networks is exactly what we need to connect the information from these layers. And with the work that Jerry and Ronak have done in collaboration with Lyle to basically translate our geophysical information into depth slices. What we're doing now is really just adding the very top depth slice to the geophysical information. We can use radar data to identify the nature of the surfaces, and we can use multispectral data to identify minerals and connect that right through the depth slices to the geophysics data that we have. And beyond that, we use the ground truthing efforts by geologists to further refine the modeling. And that is really an iterative process. We're not going to be finished with this in a one-off. We will need the results from the field to really refine this and come up with the best model. So in conclusion, satellite data is available and has proven useful in Newfoundland and Labrador. These data sets are ideal for the application of AI and machine learning. The results inform and support fieldwork efforts, but really only that. We can't rely on the model results as truths. We need people on the ground to confirm and to test what comes out of this. It's an iterative process, so the results from the ground go back into the models, refine the models, and make them better. And it is not a standalone solution. We can't take what comes out of this for granted. We need to make sure that it's actually properly ground truthed and compared to results on the ground. I like satellite data personally, but there are limitations there. It doesn't matter if it's multispectral, hyperspectral. All of this tells us something about the mineralogy, but we can't do things like trace element analyses, petrogenesis, deformation. None of that is being covered by this. So there is a risk here to take something coming out of a process like this and take it for granted and take it as a standalone piece of information. But I would like to warn against that. It can only be one piece of the puzzle, the same way that geophysics would never be used as a standalone piece of information, but only always used in context. Same thing applies here. But these sources of information are free. It really only takes initiative from our side to turn it into a really valuable resource, and we're a good way down the line with that. I'll leave it at that. Thanks for your attention, and see you around at the floor.
Thanks, David. So we're just going to move on to the last talk of the morning session. We've invited one of our federal colleagues for our sins. Roger Paulen from the Geological Survey of Canada is going to talk on some collaborative work that's been done in the Makkovik area between the Geological Survey and the of Newfoundland Labrador and the GSC.
Just waiting for the slides. There we go. Well, hopefully in your 30-year career, David, you'll have LiDAR in Labrador, because that's the cat's meow.
Love to see it.
I spoke here last year, and last year I kind of highlighted on the project itself and all the research we were doing and some of the deliverables. And initially I was not planning to come and repeat that talk here, but there were some interesting results this last summer that I thought were worth sharing. So I'm going to jump right to it because I know everybody's hungry. Just a bit of background. Yes, I'm with the federal government and with the Geological Survey of Canada, and I am the project leader for one of the GEM Geo North programs that's operating in Labrador. I'm not going to read this verbatim, but it's $100 million to fund research in the north between 2020 and 2027. And what we call the north is the line of discontinuous permafrost. So it's not a artificial latitude or whatever. It's just where northern conditions susceptible to climate change and etc. are. Our rationale for coming to Labrador, well, first, I like coming to Newfoundland and Labrador. It's a great spot. I love seafood. I love working on the coast. So what this is it's a program to sort of address some key priorities that already existed with the provincial government, because this is a collaborative effort between the province and us. And also, they identified regions. They really wanted a better understanding of, in terms of tectonic evolution and glacial evolution, and as well as increased potential for base metal critical minerals. And so what we did was have three major sub-activities to address this. So one was the bedrock mapping, and that is being led by my provincial counterpart, Alana Hinchy, along with some of David's input. The superficial mapping and landscape evolution, so that is led by my partner in crime, Jesse Rice at the GSC, as well as Heather Campbell from the Newfoundland Survey. And some geochemical investigations and mineral potential mapping, which was what I talked about last year, was reanalysis of the huge lake sediment geochemistry database that we have and archives for Labrador. And what's the rationale? Well, mineralization is pretty diverse in Labrador, but it's also got, I think, a lot of potential. You can just see from the different colored dots on there all the different types of minerals, and a special interest are minerals that we are calling critical minerals for growing green and alternative energy usage. And so what this map just shows is the footprint of each activity. So the bedrock geology is highlighted with the orange polygon you can kind of see there. The green polygon is some of the superficial geology investigations, but mostly what I'm going to talk about is the blue polygon today, and that is our new geophysical surveys. It was divided up into 2 years, so this Makkovik survey was done, the west half was done in 2022, data was released last year just before this conference. The eastern portion was flown in 2023, and that data is released November 6th, which is today. We also, during the course of bedrock mapping, superficial mapping, we carry around a gamma ray spectrometer really just act as ground anchor points or data points to support the airborne data. So let's get right into it. Some of the results. Well, before I left for the field this summer, our geophysicist, Richard Fortin, came to me and says, hey, if you're in the area, you might want to go check this out. This is what the airborne data picked up not far off Makkovik. And so what you're looking at here are what's called the Black Islands. And the photo from the air obliquely is kind of looking at them from the north looking south. And then the map on the other side of the slide is the airborne radiometric data showing some anomalies at the Black Islands, and with 200-meter flight spacing units, with those are the diagonal lines that picked it up. So fairly high resolution. So I'm a quaternary geologist, so I thought, sure, I'll go check it out. I went out with Jesse Rice. The area is fairly low elevation, so it's been impacted by glacial marine washing. So a lot of rock is exposed, and what's not rock is mostly what's left of the quaternary deposits being washed away, mostly boulder beaches. So Jesse started wandering around with the handheld scintillometer, and sure enough, we started getting some really interesting noises coming out of this instrument. Those of you who work with this know what this does. It measures total count of potassium, thorium, and uranium over sort of a given area, and prospecting for uranium for decades has used this, say, in the Athabasca Basin, Thelan Basin, for tracking boulders. And so, sure enough, we found that, this thing started squawking or squealing at 14,000 counts per second, just pretty much over the moss. And then we dug up this little boulder, about the size maybe of a large shoebox. I've done a lot of work in the Athabasca Basin, and I've measured a lot of boulders with these instruments. And the values we're getting here were pretty significant. Because of the mapping we're doing in the area, we knew the ice flow. We knew which way to say, okay, well, here's a boulder. Glacial marine stuff may have rolled it around a bit, but let's go up ice. And sure enough, we started finding some rusty-colored mud boils. And then we started finding isolated mineralization in some of the samite bedrock, with some decent values in that rock, but not where that boulders come from. But then we just kept walking up ice, and then we hit this outcrop. And I didn't put the little white bubble with the numbers because I think you can probably read that, but that's not a real number you're seeing. That's the upper threshold that the handheld scintillometer will read. It won't read values higher than that, so it's pretty rich. And we got pretty excited as geologists, because as federal geologists, we tend to think about framework geology and public geoscience, but the expression is even a blind squirrel finds a nut now and again, right? So we were pretty happy to actually find this. And so we kind of mapped it out, and then we're going back to the helicopter, and Jesse's like, well, let's go up ice, or down ice a little further, and maybe see he was doing some assays on site with this instrument, and thought, well, let's get some background readings. And so all of a sudden he's walking towards this area of like nondescript rock and moss, and the thing again starts squealing, and again you can see the numbers, they're upside down. It looks pretty nondescript, but look at the values. It's again the maximum threshold of that instrument. And so we kept walking following that, and then we saw this right on the north shore of the South Island shear zone cutting through the Black Island, at least the southern part of the Black Islands. And then we could see off in the distance, the North Island, you could see that shear zone. I'm just going to kind of highlight, whoops, wrong button. So this kind of feature through here, it's kind of washed out on that image, but it is somewhat orangey, a little bit glossiness, also a bit of yellow with some uranium oxide, I suspect. This is what the expression of that shear zone is at surface when you land there. And affiliated with those rocks are a rock I've only ever seen once before in southeastern Cape Breton, also associated with shear zone. To me, I think that's a epidote blue schist with this. Smaller rocks, that's about not much bigger than, Shaquille O'Neal's basketball shoe, I'd say. And so you have to remember, like with these instruments, that's total counts. So a big syenite boulder by volume will give you a decent count sometimes. So that's not much of a rock to give you a count of 46 counts per second. That's pretty high. And again, when we took it to the actual outcrop where these rocks are coming out of, again, the maximum threshold of the instrument was reached. So we didn't collect any samples because I am a quaternary geologist, and I didn't come prepared to collect hot rocks. And transportation of dangerous goods is a nasty thing that the onus is on me, not my organization. So I'm not about to lose my house over collecting hot, fancy rocks and trying to transport them back to Ottawa. However, we did do a number of assays with the instrument. You can actually set it up vertically, and it'll actually take an assay measurement. And so we're going to release that as an open file soon. And all the mapped boulders that we did as well. So this is a new mineral discovery. It's not in the Geological Survey of Newfoundland and Labrador's MODS database. So it's highlighted there with the little red box. It's possibly a north-northeast extension along the structural strike from what's known as the Kitts deposit or Kitts trend. And so I can highlight that here as well. So the Kitts area is right here, and it's kind of along trend with that. These are part of the Nunavut government mineral withdrawn lands. So there are several representatives here from the Nunavut government, and they can explain to you exactly what that means, how they play a role in land use and so on. And so this has gotten us pretty excited at the GSC, and I think there's going to be some additional collaborative research between Geological Survey of Newfoundland and Labrador and GSC, possibly with Greg Sparks. That may happen this next fiscal year to follow up. So it's kind of an exciting find. I feel like the ShamWow guy, but wait, there's more, right? An area we didn't get to, but was highlighted on the same geophysical data release, the one being released today, is this big thorium anomaly south of Rigolet in a place called Caravella Cove. The word I'm using is significant, but our geophysicist, Richard Fortin, called this a whopping and thorium anomaly. Another anomaly equivalent size elsewhere that was discovered also by airborne radiometrics is now one of Canada's thorium mines. Don't quote me on that. I always will throw the geophysicist under the bus if necessary. We didn't get there in 2024 because it was actually outside of our bedrock mapping and superficial mapping area. But it is an area of potential interest for future collaborative research that we would like to do with the provincial survey. I'm sure the provincial survey themselves would probably like to check this out. So with that, I'm going to take us to lunch. I'm just going to make a statement here about why we do this. And this is my opinion. My management may whap my knuckles later, who cares? We're in an age of data mining, machine learning, artificial intelligence, deep learning, but you can only model so much from existing data. You still need geologists to validate your models. If you think of 135 years to map Labrador, well, imagine mapping the rest of Canada. It's a big, big country. But it's resource rich, and there's a lot of potential for future mineral discoveries, especially buried under glacial sediment cover. I think that's where the next generation deposits will probably be found. If it's at the surface, it's probably already been found. So these high-resolution geophysical surveys, but as well as geochemical surveys, new lake sediment data in basically white areas of the map, as well as boots-on-the-ground geological mapping are super important to understand Canada's geology. And the expression I like to use, increase exploration success, especially in northern Canada. So one little plug for the mapping that we're doing. I did a public outreach video. This is a really good video to show non-geologists, non-technical people the value of mapping we do in the north. And I will be we have a booth just beside the provincial's booth, the province's booth here. And I'll be putting this out on the table. I just haven't put it out yet. It's basically a one-pager summary about what I just talked about in the Black Islands and some of the work we're doing in the Makkovik area. And we have some posters up at the geophysics as well. So I'm around till the end of the week. Just corner me if you wanted to take me to the poster and discuss this stuff. Yeah. And that's a 2-scale representation of the mosquitoes in Labrador, I think.